Thank you, Robert, for the nice introduction. So indeed, today we're going to combine dbt and Python. And at the end of the session, you'll see an exemplary running machine learning pipeline where we try to beat the Bookies, and let's see what happens, if is it even possible. Maybe to gauge a little bit and to get me to know you a little bit, who has heard or has worked with dbt before here in this room? Okay, nice, quite a bit. Then that helps me a little bit. So who am I? Well, Robert already explained, so you can see I'm still very relevant with the Beetroots band. But also, aside of that, you can challenge me on lichess if you want to. And yeah, let's see who wins. Yeah, I love games all day long. So what are we going to talk about today? Very briefly, first I'm going to give a motivation on why dbt and Python could make sense for an MLOps pipeline. Then next, I'll give a quick start, and even tonight you can create your first Python model in your organization if you want to. Then we'll have a toy data warehouse that I created with dbt and Python, and it's using the European Soccer database from Kaggle. After which, I'm going to show you whether or not we can beat the Bookies. There are some design patterns that I'm using in there, which I will give a bit more context about. And to wrap it off, tonight we can eat some bitter balls together, and you can always ask me questions as well. So, why would it make sense? Well, these days, or just actually every day ever, like if you wanted to build a reliable machine learning system, the actual machine learning code that would be put into place was very minimal compared to all the rest that comes alongside of it. So first of all, you need to prepare and maintain your data. You need to do it reliably. You need to make sure that that there's no training servings queue. Then also there's all the infrastructure that you need to care about, and all of that is being done with different tools, so Docker, Kubernetes, a lot of things. And the data scientist, they got a lot to wrap their heads off, especially on organizations. What you see a lot is like, here's use case, they shove it to the data scientist, figure it out so it never breaks into production. That's a big burden to have for a data scientist, and that's why it would be very convenient if they could just continue coding in the two languages that they love, which is Python and SQL. Hence, dbt and Python could make a lot of sense, as dbt is SQL first, and recently they have introduced Python models to it, so that you can actually use all of your favorite machine learning packages. So I've seen that a lot of people know dbt already, but I'll give a quick intro on what it is and how it really helps you forward if you're working in the data team. So in essence, it's a data transformation workflow where you work in a project and you basically write your entire data transformation as being in SQL. Now, what dbt already does for you, it's doing all the orchestration, and yeah, you can really see it in a nice deck as well in the data catalog if you want. So you don't need to worry about that. You don't need to orchestrate it yourself anymore. It also connects very seamlessly into almost all data platforms out there. So that can be on-prem, can be relational, but also like on the cloud, for example, on GCP, on AWS with Redshift, to a Databricks cluster, as is what I will be doing later today as well. Then what it also helps you do is something that we all do and love and that we try for. That's configuring tests and writing documentation on our data. So this all you can also reuse documentation if you want to, and you can also configure tests so that they break or alert you in your pipeline. Then one of the main benefits of working as a team with dbt and also just the developer experience, it allows to write SQL like in a dry way, so you don't repeat yourself. It does this by leveraging Jinja, so you can actually programmatically write your SQL code, and that makes it all very much faster as well. You can also reuse functionalities by the use of Jinja macros, and a lot of these macros are already available for you as well Yeah, SQL is kind of like the common language, the lingua franca of a lot of data experts or professionals. So from the data analyst to the data scientists to the data engineer, they can all work beautifully together in a harmonious workplace with dbt. Now, since version 1.3, dbt thought like, okay, let's make our pipelines even more expressive, and to also allow you to do things that you weren't able just by writing SQL. And basically, they fit in completely in the same way. So if you would look at the DAG, it's the purple thing there in the little DAG. That would be like the Python model. So from the user point of view, there's not really much of a difference. On the backend, there is a difference, but all the SQL code would automatically run on the SQL platform. If you're connected to the cloud, like on BigQuery or Snowflake or Databricks, your Python code will be spawned to on the compute cluster. So your Python code is running on the compute cluster. But really, using the internal features of dbt, you can also make your machine learning pipeline now more powerful, and you can all integrate it into one project, really leaving out the burden of having to do all different kind of things. How does one go about it? So this is kind of like the template. So in the import, you can import anything you want, any package you want, from scikit-learn to Hugging Face. So really allowing you that expressivity. As long as it's installed on the cluster, of course. Then this is the main entry point. So it's a function called model. It holds two arguments. dbt1 is an internal object that gets created at runtime, and it holds a lot of context on your current pipeline and your DAG. So for example, you can get like parent models loaded in thanks to this dbt object. The session is a Spark session, and you'll see in the next line. So if you load in like a table or a view from in your pipeline, you're actually loading it in as a Spark data frame or PySpark. Then you do all of your transformations. So here you do all of your fancy shit. And then you return your final data frame, and you can return it in two ways. You can either return it as a PySpark data frame or as a Pandas data frame. The schema gets inferred automatically for you, and it will always write out and overwrite, if you don't do anything special, it will overwrite the table into your data platform. So I see that by sending out there like a little bit of the formatting changed, but that makes it fun. So the toy data warehouse can we beat the Bookies? So there's actually a very cool open source data set out there on Kaggle. It holds the match information of 25,000 matches in 11 European countries. And it's all ordered as a relational database in a SQLite format. And it also contains weekly updates on statistics of players and teams. Also the final odds that the Bookies provided for the match. Before I continue, who of you has a lot of experience or just a little bit of experience with sports betting? I'll sure that this doesn't exit the room. Okay, thank you, not a lot. So that means I'll need to explain myself a little bit on how odds work. We have a little example here of odds, like for a football match. And you see the odds there, like that the Bookies provide. So the home win is 2.17, draw 3.60, 3.30. What do these odds mean? It means if I bet on the home team winning, because for example it's my favorite team, then if I win and the event actually happens, I win 1.17 euro. That's my profit. If I'm wrong, then I will lose 1 euro if I had put 1 euro in it. There's actually an implied probability in there for the Bookies, and it's just the inverse. So if you divide 1 by 2.17, you actually get to 46%. Now the interesting thing is, if you do this, if you do the math, then the sum actually is bigger than 100%. So why is that? Well, this is how the bookies make their money. They actually think that the probability is lower of these events. So they might have this, and then the blue numbers, the sum is 100%. If you then do actually the expected value of profit, expected profits, if I bet on the home team winning, you'll see it's negative. And it will be the same thing for the other bets as well. That also means that if we can have like a better version of reality on the probabilities than the bookies, we might be able to make some money. Basically, if our model is better. So we'll try to predict the winner given all the features that was given in the European Soccer Dataset. I will also like calculate some features. For example, one that I'll take away further in the presentation is the form of the team before the match. That's like their performance over the last 5 games. And then so it's important that we model it as probabilities, and then we can transform it to odds as well. And then we will place our bet on the bookie and winner, where our model has lower odds, or where we have like a higher probability than their implied probability. So if you, in the same example, if the model probability would actually be 50%, then in the view of the model, there's potential profit of, the expected profit if I bet on the home team winning would be 8.5 cents. How does one architect such a thing? First of all, it's important to for me, idiomatically, it's important to do as much pre-processing as possible, still in SQL. Reason is quite simple. It's because you cannot beat these top SQL engines on all the data platforms. There's no sense in trying to beat them as well. So yeah, if it's really feasible to do, just do it. And it will really automatically have a better performance as well. Also, like these KPIs might be used for something else, dashboarding and so on. And they also can be understood by the whole team. Now, if I want to run this part of the pipeline, I can do that with a selector. A selector is a little configuration that you put where you really say okay, you just select the flow that you want to run. So here everything up until match dataset. So again, statistics, they are there. Also the team form. And then also we have our machine learning starting point, which is a match, the match dataset. Then if you go to our machine learning pipeline, so we have 2 kind of flows that were defined within the selectors. One is where we run our experimentation. Experimentation is a Python model, and basically what we're doing there is some simple cross-validation, for example, hyperparameter tuning. You train the models and you keep your best model as well. Then, since the experiment table, it also is being snapshotted. I'll explain more about that later. We also have the inference itself, which is a different flow. So that would be like your daily flow, basically, in a simulation. And important to mention here also is these Python models, they are installed, the Python code is running on Databricks, and they're using a custom Python package to have a much cleaner API. All of this is configurable with dbt project variables, so you can really design your runtime with environment variables and with runtime variables, which you just provide in your command line. Then the demo, actually the code is also, I open sourced it yesterday, so you can take a look if you want. I gave this presentation somewhere else, and then I run it live, but here I'm not doing it. So it will work, the demo, luckily. And yeah, we kind of need to put ourselves back in time a little. So let's put ourselves on the 1st of January 2016. What's our view on at that moment in time? So for example, I run the entire pre-processing pipeline, and I run it for that particular run date. Then the match data set would be, look something like this. So you see here, up until this date, we have observed the actual winner, we have observed target, but starting from that point of view, we can make predictions potentially, but yeah, we cannot train on it. So that's nice. Then we can start our experimentation. So again, we have our designated flows for those. So I just did some simple models, XGBoost, random forest, and logistic regression. Maybe who thinks that XGBoost will win? Who thinks random forest will win? Who thinks logistic regression will win? Interesting. A lot of people don't think. So then, if we run the experiment, so that is actually just the results of a scikit-learn cross-validation, and I can export it straight away to the warehouse. Now, important to mention is by default, it's write truncate. So if I run new experiments, they will overwrite my past experiments, which would be a disaster. So you take a snapshot, for example, or you could make an incremental run out of it, where you go into an append mode. Also important is to always keep kind of like the parameters and the runtime variables. So now I can actually simulate on my test set, which runs from the 31st of July up until the 1st of January. And this is the result. So I have indeed odds for everything. I also have an expected odds, and I see if my expected odds is lower than the odd of the bookie, I will place a bet, and I will, for example, Leicester, Manchester City, I placed a bet on a draw. I expected 88 cents profit. In the end, I made 3 euros on that match. Awesome. Of course, I can still lose matches. And yeah, we cannot see yet what's happening for everything starting in January, of course. This is what happens if we compare all of our models on this test segment. So yeah, actually I trained 2 logistic regressions because I knew they would be the best. Logistic regression, actually then in the second experiment, I get to close to 25 euros profit on the test set, which is an average profit of 1.5 euro cents. Yeah, and it's on 1,600 matches that I've predicted. But yeah, now it starts for real. So I see model, it works up until the end of December. Awesome. Now I can run the daily or weekly pipeline. Like, let's imagine a weekly pipeline, because the KPIs wouldn't refresh that often for football matches, and they often play like 1 game a week. So let's move ahead to the 8th of January and see what happens. If we summarize our performance, so yeah, we also see here, so this is up until the testing set, where you see the profit that we had. And then, yeah, we actually made a bit more profit on those 5 days that we had bets ongoing. So that's cool. And then, yeah, I fast forward a little bit to the 1st of February. And then we see, okay, we lost a bit of money compared to before. We're still in the positives. Yeah, and everything is running smoothly, and I have my auto bet placed, and I don't get that much richer if I play it safe. So what are some design patterns that you might have spotted and that have used, and things that I've learned also while creating this demo? First is like the dbt snapshot. It's an internal feature of dbt, and it's really, really powerful. Basically what it does, it makes you manage track history, and it does this so in the type 2 slowly changing dimension. What does that mean? It means, for example, if we take the team form and we look at the 24th of September, then the team form could be 12 out of 15 points. If they lose the next match, the team form drops to 9. The issue is I cannot go back to a previous point in time. I cannot time travel if I don't do anything, because then the first record gets overwritten. The elegant solution is to append an extra row for each update and to invalidate the previous record. And dbt does this for you really nicely. So you can just configure it as a snapshot, and you can select which variables to track and so on, and also what the timestamp is. If you apply this on a model input, you get basically the equivalent of a feature store. If you do this on the output, you have the equivalent of a prediction store. If you do this on all of your experiments, you kind of have the equivalent of like an experimentation framework and a model registry. So a lot of things that you don't need additional tools for. Another design pattern is the one with surrogate keys, which is very easy to do with the macro that dbt provides to you. So there's like this dbt utils generate surrogate key. That again, look at the theme form, it changes. You can, for example, do like a hash on all of your columns with this function, and that way you can keep track of all the predictions you ever made, and can also avoid making the same prediction twice the next day, which is especially handy if you have expensive models running. Then there are still a few limitations with respect to Python models and in dbt. And the biggest one is that you cannot reuse any Python code inside of your dbt project. So that's really like not right. That's not don't repeat yourself. So if you still keep it inside of your dbt project, you have to repeat yourself. Also, there's no Jinja support. However, how can we bypass this? It's by just packaging a clean Python API yourself, package it nicely, and install it on the cluster. As I've done here on the Databricks cluster, I had a Python package called Risk Rover that was easy to use. So I just had these 3 imports in my Python models, and that's basically it. And then it's also still very readable what's happening inside dbt. Then what do you do with respect to testing and documentation? Like Python, Python package, you can inside of that you can do your unit testing, and while the data tests, those can go inside of dbt configurations. So for example, you could have a data monitoring tool in place where you test basically if you lost more than 100 euros over the last year. If that's the case, go to rehab. Then some other tiny tips that you can do that also is kind of by experience. An important one is that try to imagine what happens if you don't have any output. Because most data platforms, they work with a schema. At the start, the schema gets inferred, but it might be if you run your code, especially if it's pandas code, that the schema changes overnight. And you don't want your entire pipeline to fail because of something like that. So it's actually, I think it's good practice to predefine your schema as a Spark schema. And you also have an if clause. If you have empty data, return empty Spark data frame with the schema. Then you can also use incremental Python models. So this is within the internal dbt object. And you can use this, for example, to if you want to run an inference, you want to be able to run inference on all the input, but you don't want to do it on things you've already done. So in your incremental code, you can say like, I'll only make predictions for things I haven't predicted yet. With the full refresh, you can still run a prediction on all of the input data ever. Then also, we've already seen this a little bit, is you can really orchestrate different and enable different flows inside of your processing DAG with these selectors. So yeah, there's a syntax for it. And that way, for example, you can orchestrate what has to run when. Then briefly, but I think it's quite obvious for everybody here, like when should you use Spark and Pandas and something in between. So Spark you use when you're working on big data and you want to that the work gets split across the workers. it's still better maybe to use pandas if you know that okay, it's a tiny bit of data, it will work as such, then that's fine. If you've developed on a small test set but you still need the big data functionality, there's since Spark 3.2 you can also use the Spark on Pandas API, where they try to make it a very seamless transition. Then also to control what's running on controlling the flow, you can use environment variables and runtime variables. Then important, don't perform too many API calls within your Python code, especially in dbt. Reason is that you depend on an external server. There might be an internal failure and the entire pipeline fails. So one of the downsides, of course, of moving your pipelines, your ML pipelines to dbt is that you have this single source of failure. So let's go to the quick conclusion, and the conclusion is basically when should you write Python and when should you write SQL inside of your dbt project. In general, you want to use the Python models when it's much easier to develop the code in Python, and it makes perfect sense, because that way you really reduce the cost of development and also like reduce the time to develop it. There's still like a very human factor to this. But if you can do it in SQL, just do it in SQL. dbt is intended that way. It's also the more common tongue of everybody in your data team. Because Python is less accessible to maybe the data analysts in your team or the BI persons. Another downside of Python as well is there are actually the optimization of your code, it really is on you. While in SQL, it's already like abstracted for you. So that's kind of like another way to look at it. In Python, there are like 100 ways or infinite ways to do the same thing. While in SQL, there's like a much clearer path, often case. Then with respect to debugging and so on. So if you're really relying on this single project, makes it very easy to communicate within the team and to also review code and so on. And we've seen that we can have full on MLOps capabilities with the dbt pipeline, pipeline now. On the other hand, if your ML pipeline fails, the entire pipeline fails as well, or especially if you have to fail fast. On the other hand, microservices, which is more traditional way, are easier to troubleshoot. And that's it. Thank you.
Thank you so much, Dorian. If there are questions, please raise your hand.
Yeah.
So this is a question from the perspective of someone who's never worked with dbt.
Yeah.
I mean, I see some features, right? Like you can do Ginger stuff to SQL, and part of me thinks, well, I've got Ginger for that already. So what, according to you, would be like the killer feature of dbt that might motivate someone like me to spend an afternoon trying it out?
Well, it's.
Can you repeat the question?
Yeah. So for somebody who hasn't worked with dbt yet, that's perspective, and he wants to know why he should move to dbt, because internal Jinja you can also just write it in Python, and you can also already template your SQL as such. I think the killer feature is really that the orchestration really happens for you. Also, it's collaboration-wise, it's also much nicer than if you do everything within Python. It's also like SQL is more like the common tongue for everyone. So that way you can combine efforts together. But yeah, also it's one project, and your entire data transformation pipeline is orchestrated entirely for you. You can do multi-threading as well. So for example, if you connect to a data platform, it automatically, you can say, okay, I want to have 8 parallel threads running, then dbt handles that for you. Also, if you're immediately leveraging also data platform, and you can write code. Also, if you're a bit clever about it, you can use macros from dbt already that are like general purpose for every database. So you can have a project initially that you wanted to just connect to, for example, to BigQuery. If you write the macros like database ignorantly, then you can just lift and shift to another thing. For example, if BigQuery costs go out of hand. I don't know if that yeah.
Yeah, I really like your creativity to use dbt also for MLOps. Specifically, if you talk Databricks and all the developments going into that with things like lakehouse monitoring and AutoML and everything, how does that compare in your view? How is this? Should you use this for MLOps if you already have Databricks, or should you go for the native features that they offer?
I think it depends a bit on the audience that you have also within your team. If you have a team with people that just love data science and they have like a tiny grasp of it and they like coding, I think this is nice because you just use Python and SQL and you don't really need to learn anything else. It's also like the main enablers to become a data scientist. While if you have all these other tools hanging around, they can be really good. But on the other hand, as well, like imagine if you change company and they then use a different data platform, then all that you learned there was for nothing. While Python and SQL, they remain to stay. Also, it makes it. What I also want to say, this makes it also easier to lift your machine learning models to production because you just have one project, for example, and it's clear what is expected. And if you already have like a CI/CD pipeline running and then you run your dbt, for example, from a container, then if you tested your code, and you can just really just push your Python and SQL code, and you have something that's production ready.
Any more questions? Otherwise, I have a final one. Are you now a millionaire doing sports betting, or?
Well, this was in the past, so like imagine if maybe if you write something that scrapes all of the bookie sites, and if you are able to also scrape all of the statistics,
Might be doable.
This is like so it's useless, yeah.
All right, thank you so much, everyone. Please give a very big round of applause.